So we're going to do an example of a ray diagram for mirrors where we place the object inside the focal length, close to the mirror. If you've seen this in class, this is like putting a concave mirror, a converging mirror, really close to your face, and you see what you've seen it. You've seen a large version of yourself. This is actually, if you're ever seen a makeup mirror, what they call a makeup mirror. They are slightly concave. All right, they're slightly concave so that the focal length might be like 30 centimeters or 50 centimeters, so that it's behind the person's head, so they're always closer to the mirror than the focal length, and their face appears bigger, so you can put your makeup on. I'm not saying I've ever done that, but I've seen them before. But it wouldn't be wrong if I had done that, right? We're not judging. Everything's cool. Okay, so hopefully you've watched one of the earlier videos. I wouldn't start with this one. I would start with the one where find the video where the object is way out here, because that one is the simplest, because you clearly go through the center and the focal point, and there's no virtual images, and so it's the simplest one. Assuming that you've done that, you've got the basics for the parallel ray, the chief ray, and the focal ray. So let's start with the parallel ray. It leaves parallel. Like so. Hits the mirror and goes through the focal point. You can pause the video to catch up. Next. If you recall in the earlier video, I used the word through in quotation marks a couple times. And this is a classic example of why I use the word through. Because the chief ray is supposed to go, quote, through the center and then hit the mirror. Well, if you leave this object and you head that way to the center, you're never hitting the mirror, right? What we mean by through is there is a line that connects the center and the tip of the object. 2 points determine a line, right? So there's got to be a line. It means that the light leaves as if it came from the center. So what I do is I line up, the chief ray is always, the first thing you're going to do is line up the center and the tip of the object. Now, what light does is it leaves going in that specific direction. But in the case of the chief ray or the center ray, once it does, it doesn't matter. It goes right back where it came from anyway, right? So what light actually does is it leaves here, goes this direction, hits the mirror, and then goes back where it came from. So it goes here and here. But in order to determine this exact direction that it goes in, I have to line up the tip of the object with the center. Now, if you're looking at this, once you get that drawn, you take a good look at that, you're going to notice that these two rays out here in the real world are never going to meet. They are definitely not going towards each other, correct? So when you see that, that is your sign that you are about to experience a virtual image. Because what your brain is going to do, your eye sees these two rays. You're out here somewhere, and you're the person going to see those two rays. And when your eye sees those two rays, that's your eye. When you see those two rays, your brain is going to say, "Oh, look, they came from," and it's going to actually put the image wherever it thinks they came from, wherever they would have met, even if that place doesn't exist. Behind the mirror, like there's like a wall behind the mirror. But that's what it does. So I'm going to have to tilt my paper to do this correctly because I don't want to mess it up. What we do is we dot that line back. We take this line, and each of the ones that your eye sees go with the one that your eye sees. And I emphasize that because the last array we're going to do, it's a little confusing as to which one I dot back. So if you remember, go with the one that your eye sees. Your eye sees this green one, so I'm going to dot it back. And hopefully somewhere in there, somewhere back there, it's a little tricky to tell, but I'm going to guess somewhere like maybe right in here is where I would expect to see my image. So there's a couple indicators that this is a virtual image. One indicator is this behind the mirror and I had to dot things back to get there, right? This is a creation of my... So, and the other indicator is that it's upright, which virtual images tend to be upright. All right, now, let's get this last ray taken care of. Last ray is the focal ray. It's going to come as if it came through the focal point. So once again, we're going to have to, the first step is just lining our ruler up with this and this. Let's discuss this one thoroughly before we draw, because it's easy to mess up. So the ray, we're going to line up our ruler between here and here. And the ray is going to leave this and hit the mirror and come out parallel. And your eye sees, not this one, everybody wants to trace that one back, it sees this one, doesn't it? So it's going to trace, we're going to trace that back. I need that to be the one that goes through here. So just like the other ones, I'm going to cheat a little bit. I got to decide, if I want to make this match up, I figure this is going to hit right about where that line is. So when I dot this back, it should be like that. Okay, so if that's the case, when I line up my focal point and my object, I'm just going to play around with things to make sure that happens. So light's going to, I line it up, light's going to leave the object, hit the mirror. It's going to go like that. And then it's going to come out parallel. Your eye is going to see this ray here and trace it back. And if we've done our job, all three rays will meet in the same spot. So what I want you to do is, I want you to, once we take some measurements, I'm going to give you, we'll measure the focal length, I'll measure the object distance, I'll measure the object height, I'll give you all those. I want you to then pause the video and do the calculations to see if you can figure out what the image distance would be. I would anticipate it being negative. What the magnification will be, which I would anticipate being positive because it's upright, and using the magnification to find the actual height of the image. And then we'll double check to see if we got it right here. So, a couple things. First, before I go any farther, our image characteristics are virtual, upright, and based on what I'm seeing in my drawing, I think enlarged would be a correct guess. But here's the thing. You don't need the diagram even. You got a third thing you can do to back this up. You've ever put your face close to a concave mirror, you know it's enlarged. All right? So I'm not surprised by that at all. All right, some distances here. Focal length. Still 5.2, so I believe I used the same radius for that. No, 5.7, sorry. So we got a focal length of 5.7 centimeters. An object distance of 2.4 centimeters. And for later on, an object height of 1.4. So an object height of 1.4 centimeters. So use those, pause the video, and see if you can figure out the image distance, magnification, and image height.